Okay, we might get started. So I'm talking about Distro Astro, which is an Ubuntu-based distribution that is being put together specifically for astronomers. It incorporates software for professional astronomers, amateur astronomers, and you might like to say armchair astronomers. There's a lot of really cool stuff in there, and really my aim today is to give you a pretty basic introduction to it, bring it to your attention because obviously it's a good thing that people know that it exists, and talk a little bit about the project, where it is, what still needs to be done, what the resource limits are, and encourage people to get involved if you can. There's a whole bunch of different ways that you can get involved to help improve this and make it a really simple way for people to spin up a Linux desktop with pretty much all of the astronomy-based tools that you could possibly need. So, it is based on Ubuntu, long-term support version. It's focused on astronomy. It includes, as I said, in fact, the latest release is particularly focused on software for professional astronomers. The next release is actually going to be focused on more for amateur astronomers. There are also some distinct gaps in the tool set, especially for amateur astronomers on Linux. A lot of the amateur astronomy software tends to be written for Windows, and my pet theory on this is that a lot of people, amateur astronomy is often a kind of a retirement hobby that people get a bit more time to devote to, have maybe a bit more money, financial resources to devote to it as well. And they tend to pick it up as something that perhaps as they're getting onto retirement, they may become a little bit more active in. I suspect a lot of the people who are writing software for amateur astronomers are people who are ex or even current commercial coders, and they tend to write what they know. So they might be writing in .NET or any of the other Windows-centric kind of things, which means that there's not the same culture of open source project-based software development. It tends to be one person working alone, and they sometimes hoard their code quite tightly. I've heard stories of people who've offered some assistance to people developing software, and they've kind of gone, well, no, it's mine. Why would I let you get involved? So there may be some, there are some tools that are included in Distro Astro that are not actually open source applications. There's a thing called Registax, which is a image processing software. It's running under Wine in Distro Astro. It is free, but it is not open. And so there's possibly some opportunities for us to step into the breach and replicate that kind of tool set, but in an open environment. They're following a naming strategy for releases that is based around asteroids. The first 1.0 release was Ceres. They're actually skipping a 1.0, 2.0, 3.0 release cycle, which is interesting. The current release has just been released a month or two ago. That's called Pallas. The forthcoming release will be called Juno, and as I said, that's going to be focused on putting some more of the software in that is focused on amateur astronomers. They have an apt repository for all of this stuff, so as they're building things that are not in the standard Ubuntu sources, they are putting them available, and by default, that repository is enabled in your sources in Distro Astro. This is a small example of some of the software. These are probably the highlights of the software that's actually in Distro Astro. There's a whole bunch of visualization tools. I'm actually going to show you a little bit of some of the virtual moon atlas and Celestia a little bit later on. There's planetarium apps, Stellarium you may be familiar with, K-Stars, Nightshade do similar kinds of jobs there. There's actually some celestial mapping tools. So if you're an amateur astronomer and you need to know what is the sky going to look like when I'm planning my observing run in 3 days' time, you can print those off for yourself. There's built-in libraries of telescope control. The INDI is Instrument Neutral Distributed Interface. So it's kind of an abstracted library that will control a whole bunch of different telescope types. There's tools for astrophotography. As I mentioned, Registax is more for amateur astronomers, Iris and some astro capture software there as well as data analysis tools, and I have to refer to my notes for the acronym soup here. The IRAF is the Image Reduction and Analysis Facility, and ORSA is the Orbit Reconstruction, Simulation and Analysis, which sounds very cool. I haven't played with that myself. Image processing, obviously you've got GIMP. There's also an astro-specific image processing utility in there. And there's an app called OpenRocket, which I will show you briefly as well, which is basically a design and simulator for model rocketry, which I think is extraordinarily cool. And there's lots of other apps built in there as well. So I just wanted to give you a quick demo. They say never work with children or animals. They also say never do live demos. Unfortunately, I'm going to ignore those rules and will, with any luck, switch to this now. Now. Damn it. Okay. There we go. You know what? I'm just going to run it in windowed mode. That way I get a start bar as well. Okay, so it's a typical Ubuntu kind of distro. Some nice, cool little, space-themed wallpapers just to make you feel at home. It also actually has a nightshade mode, which is good if you're going out observing. It basically puts a red cast over everything to help you maintain your dark adaptation. Some of the apps here now, I'm actually going to have to do some interesting stuff after I show Virtual Moon Atlas, because I'm running this, as you can see, evilly on a Mac, and the virtual machine has interesting issues with 3D acceleration in different apps. So this basically is a globe of the moon, rotatable obviously. You can search for different things. Now, the data that I'm actually using, one of the cool things about this is it's extensible, and you can actually use live dataset textures from various missions. The data that I'm using here is actually from the Chang'e Chinese Lunar Orbiter probe, and it has a resolution of 60 meters per pixel, so it's quite detailed. They put that mission up basically as a way of mapping the surface so they could find a good landing spot for the Chang'e 3 rover, which has just successfully landed and is now wandering about quite happily on the moon. So let's say we want to go to a fairly well-known crater. Oh, no, let's go back there. Crater. Just center that. No, I don't want to do that. I want to put it there. And then you can obviously zoom in, have a play with this kind of stuff. And you can see that you can actually zoom in quite a ways. And this is not rendered CGI data, obviously. This is actually the textures put on there from the photographic data that the mission did there. So I think we might be a little bit too close now. Pardon? North being up in this context? There we go, thank you. Good job. So you can get, obviously you can see a lot of fine detail and structure in that kind of thing. So in any case, you get the picture. There's a lot to explore. There's a lot of real world data that you can add. It's very simple. You basically download some texture files and then you can select which ones that you want to actually use to visualize in the app. Now, the next thing I'm doing, I need 3D rendering switched on in the virtual machine. So I'm just going to quickly shut that down and then reboot. Apologies, this is the boring part. Alrighty. By default, it puts a list of users up. You may want to change your config for login so that it's a little bit more secure than that. Okay, so if I've done that correctly, then it's going to be running with 3D acceleration, and away we go. So Open Rocket, as I said, is a model rocketry design and simulator. And it's very kind of drag and drop environment. You can select a nose cone, you can select what kind of profile you want it to have, select the body tube. I'll just do a very quick one here. You can actually do transitions to different stages and things like that for second and third stages if you're getting that sophisticated. You can add fins to it. We always need some fins on these things, not only for the aerodynamics, but also just because they're really cool. Obviously, you can turn that around and it shows you center of gravity, all those kind of things. You can pick various rocket motors and combinations of those. There is actually a way to simulate that those parameters as well, so you should get a good idea before you build your model rockets as to how they're going to fly. Stellarium is a planetarium app. Very cool, just generally to be able to see what's going to be up later in the night or at specific times or dates. It's a very cool kind of learning app for children as well who may just be getting into astronomy. That's the current time and date at this location in Perth, so that should be what we're seeing outside at the moment. And you can turn on or off atmospherics and things like that. So even in the daytime, if we switch off the atmosphere, then this is what the sky would look like if we could see during the daytime. If we zoom time forward a little bit, we can see what it's going to look like later tonight. We see we'll have some familiar friends here, and obviously there's data that is updated in real time in terms of what you will see. And so it's great for planning, it's great for learning, it's great for visualization. That's called Stellarium. I'm actually going to have links to all of this stuff that you can grab the ISOs and play with, and if anyone's not sure, wants to get involved, I've got some cards so you can contact me really easily. One of my favourite things in the world, in the context of astronomy apps, is an app called Celestia. And again, most of these are all cross-platform. So obviously, the bulk of them are probably developed on Linux first, and then they get ported to various other OSs. You can see when that starts up, it does a nice little visualization. So we focus in on Sol and then come to the Earth. This actually supports scripting as well. So you can actually script up, and it also supports planetaria as well. So there are planetariums that are actually running this even for projection into a dome. And you can script a lot of things in it. There's a couple of scripts that are very handy. I won't be showing you the Star Wars tour. There are actually a whole lot of add-ons that have not only real astronomical phenomena, planets and galaxies and things, but also people have developed add-on packs from fictional universes. So if you want to go visit Deep Space Nine, or watch the Death Star destroy Alderaan or something, you can script that up. So I'm just going to run a solar system tour, which is a really kind of nice intro to it. And you can see again, because whatever we're selected on, we get that info for that in real time. One of the, you can switch on and off various things. And so for instance, if when we get to the next planet, which would be? Good, thank you. You all graduate with honours. So let's say we get something that's visual. Okay, I'm just going to pause that there. You can switch various options on and off for visualization. So if we decided to show, we want to select, say, the orbits of moons, planets and spacecraft, and then we actually enable those orbits, we will see those overlaid on it. And you can switch a whole lot of things like that on and off. You can switch on messier objects on and off, so you can have stars shown at various intensities and to various magnitudes. You can have galaxies and nebula switched on or off depending on your visualization preferences. So if we continue that now with orbits on, then you get to see the orbits of the planets and also of the moons and so forth that are around them. Interestingly, when we head out to Saturn, you'll see Cassini spiraling its way around Saturn's orbit as well when we do that. You've got some nice stuff there. You can see the ISS, Gemini, Hubble, Friendship 7. Obviously, these are conflating various time periods together. So I might just turn those orbits off and continue on. And one of the really cool things, earlier today I was running this through when we were testing, and Kevin Vinson, who gave the presentation earlier on the Skynet, was like, oh, hang on, we've imaged those as well. We need to get a plugin into this so that you can actually visualize your data in the way that they've done for Stellarium. So I thought it was very cool that he thought that was cool when I thought all of his stuff was really cool. So there are a lot of extensible plugins and so forth. And this will take us, if we let this run, this will take us all the way out to it'll take us through all of the planets as well as Pluto. And the Pluto-Charon sections, and then it will head on to asteroids and so forth. Now, one of the interesting things, and you can turn off labels or on or off for planets and moons as well if you prefer. If you're running this as a demo for educational purposes, you might want to do one or the other. I volunteer at the Canberra Deep Space Centre, and we have a few terminals there that are running Stellarium and Celestia. And it's a very cool thing, especially to see kids, but also adults as well, playing around with this software and getting really excited because it's a great visualization tool. And think back 20 years, we couldn't have done this on high-end CGI machines in Hollywood, and now we can just run it on our laptops and desktops and things. And so we have little info sheets where we show them. So I always talk to them and say, you can actually download this software and install it on your own computer, and their eyes light up, and that's a very exciting thing. So we're out now, obviously, into the dwarf planets, not a planet. Don't blame me. Tweet Mike Brown, whose Twitter handle is Pluto Killer. True story. He actually, I think, quite enjoys the drama of all of that. Obviously, there's good reasons why that decision's been taken, because otherwise we'd have to remember 1 million planets. Well, thousands, perhaps. Interestingly, I think there's an issue with some of the asteroids that the textures, if they don't have good 3D data for the actual shape of the object, they seem to just map the texture onto a sphere. Now, obviously, most of these objects, Ceres is quite big. It's roughly spheroidal, so I think they just basically fudge it a little bit when they don't have exact details. So anyway, this goes on for quite a long time. We're not going to do that. So these are the sort of tools that are built into it. This one here is Registax, I believe. Yeah, so this is actually originally developed as Windows software. So it's running under Wine. And this is the sort of thing I would like to see us, sorry, stretching or question? Cool. This is the sort of thing I would like to see potentially developed for an open source platform, so that we have something that is completely free and open that does the same job, so people don't have to go and, if they don't want to, load up these kinds of things. Okay. So let me just get rid of that one. I'll head back to here. Alrighty. So that just gives you an idea of some of the more accessible tools in there. As I said, a lot of it is aimed at things like data processing, image processing especially, and telescope control, which is obviously a big one for amateur optical astronomers as well. As well as you've got all of the usual development tool set in there, so that it's a functional desktop, and obviously if you're developing astronomy software, it's a good thing to be using. So it also includes obviously an astronomy-themed desktop environment, wallpapers and so forth, icons, and a night vision mode that I mentioned. Now, the state of play of this project, it's only something I only became aware of it a few months ago. And it's something that's relatively new. I think they've been working on it for about a year. Pretty much it's a one-person operation. There's a guy who is based in the Philippines called Bam Gabriana. He's actually currently working on this full-time. That's obviously unsustainable in the longer term, but he found it to be a really time-consuming job to be running and managing the distro and all of the repos and doing a lot of packaging and stuff like that. There's a UK astronomer called Nick Howe. His Twitter handle, and these are obviously Twitter handles here. Nick Howe is Nick Astronomer on Twitter. He actually took the original work and then created a VM, a VirtualBox VM, that added a bunch of other software in as well. And so now they're basically, Richie Jarvis is involved in this as well. He's basically backporting a lot of the stuff from the VM into the official distro to incorporate all of that stuff. And they're kind of collaborating together. And at the moment, the ISO for the Distro Astro is available online, as is the VM, but at some point I expect that they will pretty much merge into one thing where you get a vanilla install VM as a snapshot based entirely on the distro itself. At the moment, it's only a 32-bit ISO. That's largely because BAM doesn't actually have 64-bit hardware to put this all together on. And there are a lot of plans to happen for the distro to kind of clean it up and make it more useful. The limitations on that are people, hardware, and bandwidth. So I guess I'm trying to play a bit of a facilitator role and to see how can we, as a community, help get this to where it needs to be. Bandwidth is an issue, obviously, for hosting the ISOs themselves. Most of the time, people are going to be torrenting it, so it's less of an issue, but still. The other thing we're going to need is people to seed this thing as well. So we need people to do packaging. At the moment, it's very, very intensive for 1 or 2 people. We need 64-bit hardware or people who can contribute builds of 64-bit packages. If you happen to have some 64-bit hardware lying around that is surplus to requirements and you would be happy to ship to the Philippines, then I'm sure a donation of such hardware would be gratefully received. In the absence of that, if you're able to do some packaging, then that would be a fantastic thing as well. We need mirrors for the ISOs. That's a really important thing because a lot of the people who are coming to this are not going to understand how to torrent ISOs. They probably understand how to torrent movies, but still. It's kind of a different thing in their mind. We also need seeders for the torrent. When I went and grabbed the 2.0 version to play with the updated version, I think there were like 1, maybe 2 people seeding it. It'd be really great to have a bunch of us sticking this on our machines and just seeding it all over the place. We need beta testers for new releases. One thing that is probably a lower priority but would be a really cool thing for the longer term is to have people who can actually either contribute to existing apps that are out there. And you may not have, I know all of us in this room are interested in astronomy and we're interested in Linux. We may be devs or whatever, but we may not have thought about contributing to astronomy-specific projects. That would be a really cool thing to do. Or, write your own app and get it included in something like this. And then all the other ancillary stuff, they need better logos, better branding, website copy, all that kind of stuff. They want to build a forum and a bit of a community around it, so people who can lead that. And really, I guess, what I'm doing today is the largest part of this is just evangelizing this kind of thing to the Linux community and to the astronomy community, because there's a lot of people in amateur astronomical societies who will be running only Windows stuff, and they may not be aware that there is a huge amount of stuff available on Linux. So this may be the gateway drug, if you like, to converting people to Linux, because I hear that 2014 is the year of Linux on the desktop. Just a rumour. So how to get involved? Come and talk to me. Come and find me when I'm around about the conference. As I said, I've got some cards here if you want to drop me a line, an email or a tweet or something like that. They do have a contact form on the DistroAstro website. More importantly, grab the ISO, install it natively or under a VM and start playing with it. Hook it up to your telescopes. Use it in your projects. And maybe talk to your people at your lugs about it as well. Do a demo. Pass out some CDs, some DVDs, whatever. If you're a member of an astronomical society, talk about it, run a demo, give a presentation, do a talk, and I suspect you'll find that a lot of people just have no idea that there's this wonderful software available to them for free that can do all these fantastic things. How to get it? The ISO is 2.1 gig. At the moment, torrenting is preferred, obviously, because bandwidth is a constraint. At the moment, the hosting is being donated by somebody, and I'm looking at maybe donating some hosting and bandwidth as well, but they get to a point where they hit their bandwidth limit for the month. Yeah. Pardon? Excellent, sold, thank you.
I can host that for you.
Awesome.
I'm on it.
Thank you. I've made notes, it's on video. Can't get out of it now. Sorry, Andrew, do you want to get on through? Alrighty. Excellent, a couple of offers. Anyone else, the more the merrier. And obviously, seeding it. Please, please, please grab it and seed it. That would be fantastic. At the moment, you can grab it here. I made some little tiny URLs because the existing ones are ridiculously long. DistroAstro 2, DistroAstro 2 Direct if you want to just grab the ISO, or grab it from their website. But that's the kind of the longer way to do it. These are the contacts, and look, I'll make this slide deck available. I'll put it up on a link to it on the wiki and send something to the chat mailing list about where you can grab this. These are all the details. DistroAstro on Twitter is the most obvious one. DistroAstro.org is their website. Bam Gabriana is here. Richie Jarvis, who is doing most of the backporting. Nick Howes, who looks after the VM side of things at the moment. So that's pretty much it. That's my details. As I said, grab a card, whatever, and come talk to me. Any questions? Crickets. Excellent. Yeah, hi.
Do you have any idea, just out of curiosity, why it's a derivative of Ubuntu rather than this Debian-based distribution?
The question is, why is it based on Ubuntu rather than just pure Debian-based? Short answer, I don't know. Presumably, and I don't think BAM is necessarily a guru, and I think he's learning as he goes in terms of packaging and managing a distro. I suspect it was either he's using Ubuntu or Ubuntu is really, really popular, and therefore it's dead easy to install, all that kind of stuff. And so especially if you're trying to gather up people who are new to using Linux on the desktop, it's probably a more gentle, user-friendly introduction, and so I think that's probably the basis there, but I'm guessing a little bit. But yeah, I would think it's basically ease of introduction. And I think they're picking up some of the components from Mint as well in terms of desktop manager and stuff like that. So it's kind of aimed at what is the easiest way to get people into using this desktop environment. And we want to populate it with a whole bunch of really cool astronomy tools as well. Yep. Any other questions? No? Awesome, thank you. Well, we have a couple of offers already of bandwidth and mirroring, so that's fantastic. And yeah, I'd really love to see everyone getting involved, and let's make this thing something awesome. Thank you.